A loose or broken neutral connection can cause voltage imbalances, resulting in lights brightening when large loads are turned on. If the neutral wire is too small for the load, it can overheat and cause voltage drop, causing the lights to brighten. Despite having a cold water ground, the absence of a ground rod may indicate insufficient grounding. Loose connections within the breaker panel can lead to voltage fluctuations, causing lights to brighten. A malfunctioning appliance with a faulty ground or neutral connection can cause voltage imbalances, resulting in the lights brightening. To troubleshoot, firstly, inspect the main neutral bus bar and all neutral connections in the breaker panel, including the meter base, and tighten any loose connections. Secondly, verify neutral conductor size. Ensure that the neutral wire is of sufficient size for the load. Refer to the National Electrical Code, or NEC, for sizing guidelines. Thirdly, install a ground rod. Drive an 8-foot ground rod into the soil near the electrical panel and connect it properly to the grounding system. Fourthly, inspect breaker panel connections. Inspect all circuit breakers and bus bars for loose or scorched connections and tighten or replace as necessary. Fifthly, test appliances. If possible, test each large load appliance individually to identify any potential faults. Determine the total load of the house and ensure that it does not exceed the capacity of the 150 amp service. Measure the voltage at various points in the house, including the main panel, when the large loads are turned on to help identify voltage drops and imbalances. Let's delve into each of these potential causes and troubleshooting steps in more detail. Starting with neutral faults, the neutral conductor provides the return path for current in an electrical circuit. If this connection is compromised, it can lead to voltage fluctuations. When a large load is switched on, the voltage can momentarily spike, causing the lights to brighten noticeably. This is often most apparent with incandescent bulbs, but can also affect LED lighting to a lesser extent. To thoroughly check for neutral faults, begin by examining the main neutral bus bar within the breaker panel. Look for any signs of corrosion, discoloration, or physical damage. Ensure that all connections are tight and secure. Next, inspect all neutral connections throughout the panel, paying close attention to where the branch circuit neutrals connect to the bus bar. Use a torque screwdriver to tighten the connections to the manufacturer's specified torque value. Also, it's important to inspect the neutral connection at the meter base. This is where the utility's neutral conductor connects to the home's electrical system. A loose or corroded connection at this point can also cause voltage imbalances. If you are comfortable working at the meter base, carefully inspect the connection and tighten it if necessary. However, always exercise extreme caution when working around electrical equipment, and if you're not comfortable, contact a qualified electrician. Now let's consider the size of the neutral conductor. The National Electrical Code, or NEC, specifies the minimum size of conductors based on the expected load. If the neutral wire is undersized, it can become overloaded, leading to voltage drops and potentially overheating. To verify the neutral conductor size, you'll need to consult the NEC tables. Table 310.15. B16, formerly Table 310.16, is commonly used to determine the ampacity of conductors based on their size and insulation type. You'll need to know the total calculated load for the house, including both general lighting and appliance loads. Once you have the total load, you can use the NEC table to determine the minimum required size of the neutral conductor. Keep in mind that the neutral conductor must be sized to carry the maximum unbalanced load, which is the maximum difference in current between the phase conductors. If the existing neutral conductor is smaller than the size required by the NEC, it should be replaced with a properly sized conductor. Moving on to grounding. Proper grounding is essential for electrical safety and helps to stabilize voltage. A ground rod provides a low impedance path for fault current to flow back to the source, helping to trip circuit breakers quickly and prevent electrical shock. Although the home has a cold water ground, the absence of a ground rod may indicate insufficient grounding. The cold water pipe can corrode over time or be replaced with non-conductive materials, which compromises its effectiveness as a grounding electrode. To install a ground rod, choose a location near the electrical panel where the soil is moist and free from obstructions. An 8-foot ground rod is typically required. Drive the ground rod into the soil until only a few inches remain above the surface. Use a ground rod driver to make the process easier. Connect a grounding electrode conductor from the ground rod to the grounding bus bar in the electrical panel. Use a listed grounding clamp to make the connection and ensure that it's tight and secure. Next, let's inspect the breaker panel connections. Loose connections in the breaker panel can create resistance, which leads to voltage drops and heat buildup. Over time, these loose connections can worsen, potentially causing arcing and even electrical fires. To inspect the breaker panel connections, first turn off the main breaker to energize the panel. Then carefully remove the panel cover, being mindful of any exposed wires or components. Visually inspect all circuit breakers and bus bars for signs of looseness, corrosion, or scorching. Pay close attention to the points where the breakers connect to the bus bars and where the wires connect to the breakers. Use a torque screwdriver to tighten any loose connections to the manufacturer's specified torque value. Be sure to follow the NEC guidelines for torque values, as over-tightening can damage the connections. If you find any scorched or damaged breakers or bus bars, they should be replaced by a qualified electrician. Faulty appliances can also cause voltage imbalances and bright lights. A malfunctioning appliance with a faulty ground or neutral connection can create a path for current to flow through unintended circuits, leading to voltage fluctuations. To test appliances, start by unplugging all large load appliances, such as the dryer, oven, coffee maker, and microwave. Then turn on the main breaker and check the voltage at various points in the house. If the voltage is stable with all appliances unplugged, then you can start plugging them in one at a time to see if any of them cause the voltage to fluctuate. Use a multimeter to measure the voltage at an outlet while each appliance is running. If you notice a significant voltage drop when a particular appliance is turned on, it could indicate a fault within that appliance. In that case, it's best to have the appliance inspected and repaired by a qualified appliance technician. Also, consider performing a load calculation. Determining the total load of the house helps to ensure that it does not exceed the capacity of the 150 amp service. An overloaded electrical system can cause voltage drops and other problems. To perform a load calculation, you'll need to add up the wattage of all the electrical devices in the house, including lighting, appliances, and heating and cooling equipment. The NEC provides guidelines for calculating the load for various types of equipment. Once you have the total wattage, you can convert it to amps by dividing by the voltage. For a 120 volt circuit, the formula is amps equals watts divided by 120 volts. For a 240 volt circuit, the formula is amps equals watts divided by 240 volts. If the total calculated load exceeds 80% of the 150 amp service capacity, it may be necessary to upgrade the service to a larger size. Finally, consider voltage measurement. Measuring the voltage at various points in the house, including the main panel, when the large loads are turned on helps to identify voltage drops and imbalances. This can provide valuable clues about the source of the problem. Use a multimeter to measure the voltage at the main panel, at various branch circuit outlets, and at the terminals of large appliances. Take voltage readings both with and without the large loads turned on. Compare the voltage readings to the nominal voltage of the system, which is typically 120 volts or 240 volts. A significant voltage drop when the large loads are turned on indicates a problem with the electrical system, such as a loose connection, undersized conductor, or overloaded circuit. If the voltage is significantly higher than the nominal voltage, it could indicate a problem with the utility's voltage regulation equipment. By systematically checking neutral connections, verifying neutral conductor size, installing a ground rod, inspecting breaker panel connections, testing appliances, performing a load calculation, and measuring voltage, it is possible to identify and resolve the issue of lights brightening when large loads are activated. However, if the above steps do not resolve the issue, it is recommended to consult with a qualified electrician for further troubleshooting and repairs. Electricity can be dangerous, and it's always best to err on the side of caution when working with electrical systems. A qualified electrician has the knowledge, skills, and equipment to safely and effectively diagnose and repair electrical problems.